In practice, every modulating signal will have a range of frequencies from 20 Hz to 20 kHz, and hence I will not see only a discrete frequency component like Fc plus Fm or Fc plus 2Fm and so on. Starting from Fc up to Fc plus Fm, there will be range of frequencies, and also from Fc to Fc minus Fm there will be all the possible frequencies in that range. Because in any practical modulating signal we will have all the possible modulating frequencies from minimum to maximum, and hence there will be all the frequencies present between Fc to Fc plus Fm and Fc to Fc minus Fm. Fm in that case will simply serve as the maximum modulating frequency, which could be 20 kilohertz, let's say, in any audio signal, or if it is, let's say, a speech signal, then it could be somewhere around 3.3 to 3.4 kilohertz. Let us quickly start talking in terms of frequency bands and not frequency components. So I repeat, from Fc to Fc plus Fm will be the first upper sideband which the Fm signal will have. From Fc plus Fm to Fc plus 2Fm will be the second upper sideband the signal will have. Similarly, from Fc plus Fm to Fc plus 2Fm, there will be the third frequency upper sideband that we will have. So you can see that there is not just one upper sideband and one lower sideband as we had in case of amplitude modulation, especially in case of double sideband a full carrier. Here there are multiple sidebands. On the other side, you can see starting from Fc to Fc minus Fm is first lower sideband. After that, from Fc minus Fm to Fc minus 2Fm is second lower sideband. From Fc minus 2Fm to Fc minus 3Fm is third lower sideband, and so on. So right now we have shown 1, 2, 3 upper sidebands and 1, 2, 3 lower sidebands. There will be multiple sidebands. Theoretically, there will be infinite sidebands on both the sides of carrier frequency. And hence, when you calculate the bandwidth, the theoretical bandwidth of FM signal is equal to infinite. So when you talk about a mathematical signal and its bandwidth, it comes out to be infinity. We know that we can't transmit a signal with infinite bandwidth. We will have to restrict the bandwidth to some finite value. We will see how to do that. Before that, one more important point which we like to understand right now. See, as the frequency components are increasing in their values, as you go away from Fc on both the sides, we are not defining very perfect nature of amplitudes as of now. But one thing is for sure, if you go from Fc towards the higher and the lower side, the overall amplitude of the frequency components will decrease. And that means if you consider one of the higher upper sidebands or lower sidebands, then let's say, for example, if I talk about something which is in the form of Fc plus 10 Fm, or for that matter Fc minus 10 Fm, in that case you will have that sideband existing, but it will be existing with very low amplitude. The point that I'm trying to make is the low amplitude would indicate low power, and hence the majority of the power of the signal will be concentrated in the first few sidebands around the carrier frequency, and the higher sidebands on both the sides will not contain large amount of power. Power, in other words, will be the amount of information. The frequency range in which you have more power contains the more information. So higher sidebands on both the sides will not contain a lot of information. So this is one point which will help us to finite the bandwidth of the signal. I will transmit those sidebands only which are helping me to transmit the maximum power and hence the maximum information. I will remove all the remaining sidebands, and hence I'll be transmitting finite number of sidebands. With finite number of sidebands, the bandwidth of the signal will also be finite. So before we proceed and talk about bandwidth and few more things, let us write down one more important result: bandwidth of each sideband, whether it is upper or lower. For example, there is a sideband from Fc to Fc plus Fm, or from Fc plus Fm to Fc plus 2Fm. Similarly, there are sidebands on the lower side also. Bandwidth of each sideband is nothing but Fm. If I tell you that there is an Fm signal where I'm transmitting 5 sidebands, then how much is the total bandwidth that I will require? It will be nothing but 5 into Fm, because Fm is bandwidth of one sideband. But that is not how we are going to calculate the bandwidth. In most of the cases, we first decide the bandwidth of the signal which I want to transmit, and according to which we will later on figure out how many sidebands we have to consider so that we get that much bandwidth of the signal.